I'm going to present you a little bit more in detail the hardware part and software part related to what Hussein explained before. So at CSCS, we have mainly three kinds of file systems based on GPFS. Two of them are really small and used only for the user. So not normal bandwidth, always backed up, and small size per user available. And the other two are the two that Hussein explained before. One is the project, so used for our project submitted by university and not really a customer for us, but only the community we support. And this file system has a high bandwidth, and it's always backed up. And the capacity for each project depends on the proposal we received. And the other one is Store, that is the new file system we introduced during last year that is based on a new kind of hardware, and it's really chained to the TSM, HSM part. So it's the real hierarchical file system we have. And obviously, it's related and it joined the contract that CSCS has with the customer. So really a fast overview about the hardware we have on project that Hussein already explained. In the last, which is the pointer? Is this? Yes. The part we had in the last year was this one, the metadata part that we moved from the fiber channel to the SSD, just to have a better delay on the metadata part. So it's good for GPFS because when you apply policy, you mainly work on the metadata. So if you have an SSD, you have an improvement. It's faster. And the TSM storage agent, that those three machines are directly attached to the tape system. So these make fast the process to save the data directly to the tape without any network delay or just using the fiber channel part. Exactly the same for the home apps. We have one machine dedicated for the backup that is directly attached to the tape, so you save a lot of time because you can skip the cache part of TSM. So you have not to do two steps to save the data, but just one, going directly to the tape. And the last file system is Store. That is the new one we have that is based on DDN hardware and obviously metadata on SSD. And also here we have two machines that are storage agent that directly save the data on the tape. And in the last year, we introduced also the cluster NFS part that is provided by GPFS. That means that you can access GPFS not only using the GPFS layer, but you can access using NFS, that it's really common and really easy to use. And cluster NFS because you point to an alias, and then if you switch off one machine, the alias go to another machine, and you have no downtime. And it's really useful for us that we are sysadmin and we have to work on the machine. So the users has no stops, and we can work and upgrade the system without any problem. And the really huge operation we have done in the last 4 months is move from the old HSM file system we had at CSCS, so the QFS, SAMFS, the one provided by Sun Solaris before, now Oracle. And we moved to GPFS plus TSM. And we did this work using a tool provided by HMK, a German company that helps us doing the migration of a really huge amount of data, like 650 terabytes of data and 26 million of files. So mainly we did like a snapshot as a first step, freezing the metadata at that date, moving only the metadata to the GPFS part using the HMK tool. So after this, we start to move as a bulk migration all the data from one system to the other one, leaving the production on the old systems, on SumFS. At a certain point, when we finished the transfer of the huge amount of data, after 3 months mainly, we did the last synchronization, so doing another snapshot, stopping the production on SumFS and moving all the files to GPFS, taking half a day, more or less. And after half a day, we moved the production to the new system, GPFS and TSM. Obviously, after the migration, all the data were on disk. And so we moved from September to December, as I told before, 26 million of files and 600 terabytes with an average speed of 7 terabytes per day. This speed depends on, obviously, on tape drive speed, on network speed, and GPFS performances. The tape drive speed was more or less 100 megabytes, but the bottleneck was the network speed, because the server we had before GPFS was a Sun Solaris with a PCIX, so only 3 gigabytes a second. And this was the bottleneck. So we moved a file system with this kind of topology of data. As you can see, the biggest part of data were between 100 megabytes and 1 gigabyte. So not really a small file size, not really a huge file size. That means it's a disaster for the tape, because when you read this kind of file, you have a shoe shine effect on the tape, so you lose time. And this was because we took 3 months to move the data. So after the migration, we jump on this new infrastructure that is based on TSM, HSM, and we have mainly one TSM server per each file system that is connected to one other TSM server that is able to manage the library. Why we choose to have another TSM server to connect to the library? Because we want to share all the 24 tape drive. In this case, you can use 24 drive on one single file system if you need, because otherwise you have to buy 48 tape drive. So you save money, you save time, and you can use all of them. And mainly is what Hussein told before. So now we are doing we have done a first copy of project. We are finishing the first copy of /store. And obviously the data topology is like I showed before. So it's a long procedure to save on tape. But after the first run, it's really fast. And we are doing this operation using the Backup, that is a utility provided by GPFS that use the GPFS policy to analyze all the metadata and produce a list of files that has changed during the time between one backup and the other, doing the list and using the TSM tool to save on tape. So this is not really a paradise for the moment because it's under construction more or less by IBM. We have a problem on the catalog of errors between TSM and GPFS, because they are both IBM software, but they are working together since a few years now, and they are building a really helpful group of utilities. But now, what we have more or less every time, we have an error where GPFS is not able to build a shadow database that saves a lot of time. It's not a blocking error, but every time you have to do a backup using GPFS and TSM together, you need 10 hours for our file system, our sites, to rebuild the shadow database and start the real backup. So mainly it's not a problem, but it's something that we are going to solve with IBM. We are working very hard to solve, and we are in touch with the lab, and we have an advocate in Mainz with the HSM team of IBM, and they are working, they're producing fix really often, but we are not reaching the last fix now. So after that, I can show you two future plans about GPFS at CSCS. We want to introduce a new GPFS file system, a small file system, but with a nice feature. So a tiered GPFS built on SSD and fiber channel disk, just to move data across the two kinds of disks, depends on access time and the project we need to process with an high speed or not. It's a new project. And obviously, to finalize the project of disaster recovery we started last year, we want to use the feature provided by TSM 6.3 that is a TSM replica. So build a new TSM infrastructure in another site, not in Lugano, but somewhere else, doing a real-time copy of TSM. So in case of disaster, we just point to the new TSM and we are safe.